thank you for the opportunity to speak here today, both to yourself and to everybody up there in the outer world. It's a bit unique this for me because I'm used to speaking at lots of other venues around the world on this subject. So coming from Staffordshire, it's something quite special for me to be able to actually speak here in my hometown area. Originally from Blythebridge, then Mere Park, and now live in Stone in Staffordshire. So I'm right on your corner doorstep. So what is this going to be about? What is the subject on this? There's a delay. Got to get used to that. So before I get into the value stream reference architecture, I think it's important to set some of the basics around what is value stream management. Does anybody here know what value stream management is, or heard of it, or understand the concepts? There's nods in both directions. So forgive me if I'm going over stuff that you know, but hopefully you'll learn something a little new from this, who knows. But it's important about what it is and what it means for IT. Because this is something that's very new for IT, but it's not new in the business world. Typical. Now the clicker stops working.
There is a question there. Any connection to lean value maps?
Do you want to take questions as
it's lean, yes, lean value maps is linked to it. Oh, hang on a minute. Is it because the OK on there?
Oh, might be.
Yeah.
Yes, could be if you go
Yeah,
OK.
I've got to click on that, haven't I? There you go. That'll be the reason why.
Excellent.
So let's provide you with an introduction into value stream management. So although value stream management is new within IT, it's something which has actually been around for over 100 years. And in fact, some would argue it's actually been around for 500 years. But I won't go into that much detail with you, but the first modern interpretation of it comes from the Ford manufacturing line. Henry Ford putting things on a processing line, getting from that beginning, assembling everything on the assembly line and getting to the end. And as has been pointed out, any connection to lean value maps, the Ford manufacturing line system was obviously then perfected later on into the Toyota production system, which is used as the basis for much of our lean engineering knowledge and has lent into what we know today around agile, around Kanban and those various methods. That was later perfected by Taiichi Ohno and in the Toyota Way by Jeffrey Leica. Along the way, we've also had books on the lean methods, like The Goal from Dr. Aleo Goldratt, who's written about the theory of constraints. But in terms of where we are with IT and where it comes into IT, the key turning point was in 2018, when Forrester produced a report on value stream tools. And it was the first time that anything had been done in terms of any intensive research of value streams within IT. Shortly after this, the Value Stream Management Consortium was founded, of which I've been a member since day one, and I'm now proud to be an ambassador for that consortium. So that's a brief history of how we got to where we are today. But here's the definition of it as it comes from the Value Stream Management Consortium. So important elements are in bold, but I'll stress those in a moment. I'll just read that out. Value stream management means you connect from idea to value realization, integrating your DevOps tool chain end to end, and gain unparalleled insights into what's happening when your teams are delivering value outcomes to your customers. Now, there's certain important statements there. The first three are those. Why are they important? Well, DevOps tool chain, that's talking technology, that's your tools. End-to-end and gain unparalleled insights, or the end-to-end, that's your process. Unparalleled insights means it's measured. So a measured process. And finally, teams. Teams are made up of people. Now, I don't know about you, but I've been around for 30 years in the IT industry now. In fact, over 30 years in the IT industry. And in that time, I've done CMM, CMMI, TOGAF, ITIL, Prince2, you name it, SAFE. Just think of a few more out there, XP, Agile, other methodologies. And in that time, three things have always been consistent. People have always talked in terms of people, process, and technology, that great iron triangle that exists. So that is upheld also within the Value Stream Management Consortium. But there's two important differentiators of how Value Stream Management looks at this and looks at the implementation of DevOps. First of all is that unparalleled insights. It actually stresses the need for measurement and for metrics, whereas in the past that hasn't necessarily been, in fact, it never really has been adopted, has it? We've always been a bit light on measuring how we perform and what we're actually delivering. But it's this part that's the most important part, delivering value outcomes to your customers. Because this is what the focus of Value Stream Management is about. It's not about outputs. Don't know about you, but when I started in the DevOps world and I went to a meetup event, you always heard about Netflix doing 100,000 distributions a day and how they managed to resolve 1,000 incidents in an hour. Fantastic, great outputs, but what is the outcome? How does that actually help in terms of a business? You know, I could go to a financial bank and say, right, you can now do 50,000 deployments a day, but how does that help them in terms of their customers, getting a mortgage, getting a loan, arranging the credit cards, ensuring that there are bank transactions which are occurring? None of that means anything in terms of their actual business outcomes, which is what Value Stream Management is about. So that's the basis of the definition. If you want to find more, go into more detail about Value Stream Management, please go to vsmconsortium.org. That's the website for the Value Stream Management Consortium. I'll just highlight some key things on there. The VSM taxonomy. So there's literally a taxonomy of terms in there, including value stream reference architectures, that tells you about the terminology that's used so as to bust some of those, the language that you hear going around. There's some very good blogs on there, some very good write-ups. Events, Flowtopia. We've just recently had the Global Flowtopia event. It was an online event, global, around the world, well received that. We also have some local events. We had a Flowtopia event in London just a couple of months prior to that. They've got their own YouTube channel as well, where you can go see various discussions with key people in this area from around the world. Research, this is extremely valuable. Every year, the Value Stream Management Consortium produces a State of Value Stream Management annual report. Great place to go to get more information, but also to see over the years how historically this has grown and what's occurring in the marketplace. And there's various memberships available to them. So that's where you can go for further reading about Value Stream Management itself. But what is the market saying? What's happening in the marketplace? Is this really a big thing, or is it another buzzword? So Gartner, for example, in 2023, stated that by 2026, 80% of organizations will use Value Stream Management to align their software delivery priorities with business objectives. That's a big number of the industry that's out there. So think at the moment, if your industry or if you're where you're working, if they're not working in Value Stream Management at the moment, need to catch up. It's a good place to catch up. And that is projected also in terms of the business market, the size of it. As you can see from this market research projection, we're talking of an increase from just under $500 million in the market size from 2023 up to just under $1 billion by 2031. So an explosion in that market over the next 6 to 8 years. But I'm not a salesperson. I'm not here to talk numbers with you. I'm here to talk about what Value Stream Management is. And this is really playing up. Sometimes it works, sometimes it doesn't. Yeah, please, if you could. Sorry. Thanks, Craig. You going? Something popped up. Oh, hang on. It's because that.
Ah, yeah, it's got that.
Yeah, it's whenever something pops up. That's what it is. Yeah. Probably better. Technology. If it worked perfectly every time, we'd all be out of a job. So why is it needed? Why is it important? I noticed on our guest list today is Craig Statham, Dr. Craig Statham. He is actually the co-author of the Value Stream Reference Architectures paper with myself. And a lot of this comes from discussions that I've had with him. Because I was coming from the theoretical side of, here's value stream management, here's this new thing, this new discipline that we're growing. He was coming from the pragmatic side. We're doing DevOps. We're not necessarily getting the value out of it that we want to. Why not? Is value stream management the answer? There are three key issues that occur in DevOps today. So whether you're doing a DevOps implementation now, or you're considering one in the future, or if you've already done one and you're finding problems, these issues are probably going to be fundamental to you. Number one, Conway's Law. Who knows Conway's Law? Got one hand over here, one over there. I find it kind of hysterical that we're getting all excited about AI over the last 2 years, when this is something that's existed since the 1960s and is still a problem today. What Conway's Law is that's in the quotation there. Organizations which design systems are constrained to produce systems which are copies of communication structures of these organizations. Or to put it in layman's terms, you think your enterprise architects or your solution architects have been defining and designing your systems. No, HR have. Because it's typically how your organization is set up and how they communicate that actually defines your architecture. If two people are constantly talking from two separate teams and they talk about that great piece of code that they've got that they want to share and somebody else shares it, the moment they share it, you have potentially created an integration between the two. And if that integration is tightly coupled, you've created a dependency. Now, in the world of, and where Conway's Law can be seen, in the traditional world, we've built these great big monolithic structures. And what we've had is great big monolithic IT departments that have been split by functions of design, develop, test. And so you've resulted in this massive system, and there is problems in the process, in the flow, in how it's delivered. Going over to Agile, we've split our teams into smaller functions, and we've got smaller microservices and smaller APIs. But then this is where we've hit the first problem, is that we're told in DevOps there should be no silos. Everybody communicate, everybody talk. So everybody does talk and communicate, and what happens? All of those little microservices become tightly coupled. And you end up with what's called a monolith of microservices. And you reach the kind of issue which Craig has found in the past, and many other people I know have found in the past. You've gone from a monolithic project which takes 18 months to deliver. Your Agile brings it down to 2 or 3 week delivery periods, and then that starts to expand out. Because you're having to get more and more impact assessments from other teams where you have that tightly coupled architecture. That leads you then into the second issue. The second issue being, just catching up. It's quick, isn't it? Is it going?
Place bar on that. I've just admitted someone, but it seems to be moving on.
I would just use that from now on, yeah. Issue number 2, mid-tier stickiness. So Puppet is an organization which produces regular state of reports on the state of DevOps. This report was from 2021, and I'm afraid to say it's not changed in the years since when they have reported upon this. But you can see that from 2018 to 2021, we have this mid-tier. What this is at the top, you've got these high-level organizations which are achieving the level of maturity that they want, but it's only a small amount. The vast majority, 78%, are stuck in that mid-tier. That means they're implementing DevOps, but they're not getting everything out of it they want to. Now, further analysis of that is upheld by this quote from Patrick Dubois, the godfather of DevOps. DevOps is whatever you do to bridge the friction created by silos, he said, in defining DevOps. All the rest is engineering. What he meant by that and what was discovered is that most of these mid-tier organizations were implementing the tools, they were doing the automation, but they weren't changing their culture. They weren't leaning their processes. They certainly weren't doing it to the extent in which they were doing the automation because they were thinking the automation would do it for them. The net result, they're not reaping all of the benefits that they can get from the system. So, issue number 3, tool chain sprawl. And this is as a result of the great Agile Manifesto and the way we moved, in that we gave autonomy to all of our teams to go and pick whatever tools that they want. Now that's great, and because we've got orchestration tools which allow them to move from one step to the next and do whatever it is that they need to do. But the problem is you will have one team who, as research shows from both the GitLab Global DevSecOps Survey and backed up by reports from the Value Stream Management Consortium, individual teams can have up to 10 tools. And with shift left and more effort being put, more expectation being put on the developer, that means they're having to work with a development tool, a security tool, a testing tool, the list goes on. Developing the infrastructure, creating the infrastructure as code. It's putting more and more cognitive load on the developer. And there's a lot of context switching required between there. And what's more, as is shown in that bottom table from the Value Stream Management Consortium report, all of this information is held in separate data and databases, all of which are in different structures and made up in different ways. And to get that information together, to get visibility end to end of your value stream is extremely difficult. Over 50% are relying on aggregating that information from several sources into one source onto a dashboard, or even worse, manual collection from several sources into spreadsheets. The result is often inaccurate data, and certainly it's very historical data because by the time the analysis is done, you've already moved on and you may be a sprint down the line or several weeks down the line, and by then things have changed, things have gone on, things have moved. What you need is information that is available in real time and available immediately, because you need to be able to respond as quickly as possible to any kind of constraint or problem in your delivery. So the result is that you put those things together, which is Conway's law, which results from a poor organizational structure not aligned with the architecture that you're delivering. Your mid-tier stickiness, which is a symbol of poor process definition, the lean engineering isn't in there. Your tool chain sprawl, which is down to poor tool management, plus a focus on outputs, such as defects and so on, that's what you're measuring, and you end up with what Craig nicely called a messy ball of wool. It's impossible to see what's going on. It's really hard to actually do anything to work with it. What you actually need is organized teams, lean processes, consolidated tools, and a focus on outcomes. And that is what you saw in that definition of value stream management. So hopefully now, anybody who has not understood value stream management is seeing it now and knows what the definition of value stream management is. So that's my introduction into that. How is it implemented? There's this thing called the Value Stream Management Implementation Roadmap. It's an 8-stage process where you first of all assess where you are at the moment. You set a vision, which is based upon your business outcomes you want to achieve at the end. You identify your value streams, organize around them. You map your system to the organization, the people, and the value streams and the processes that they deliver and the measurements that you require to deliver the vision. And then with that map of everything, you can implement it within a tool, which is the Connect stage. Once it's connected, you can then inspect using those identified measures. And with that inspection, it allows you to continuously improve, which is the adapt stage. Now, I've talked about that in the stereotypical left to right. However, in the real world, we know everybody implements these things right to left. So they start with the tools, then they think about the processes, and then they go into everything else. So this is where you can implement using, I come from GitLab. So GitLab is a tool that allows you to connect all this capability, have a single vision, a single platform that allows you to then inspect and adapt on those things. But that's all well and good, but GitLab can only do that if what you've put into the tool is what you really need. Is it lean? Has it got all the right people? Have you got the right measurements? And that's where value stream workshops come in. So value stream workshops allow you to map where you are at the moment. And it's where this book that I'll mention in a moment or two comes in, Flow Engineering. Steve Pereira, good friend of mine in Craig's, has written that book. That's the latest one to come out from the IT Revolution Press, where you look at your outcome maps, your dependency maps. You look at your current state, you look at your future state, and that helps you to identify for a value stream how you need to improve in order to deliver value into a customer. But the thing is, those value stream workshops typically only work on a single value stream. And as you probably know, for most businesses, there is more than one value stream. Value streams can be dependent upon what the business services you apply, what tools you provide. So you think in the finance industry, there's mortgages, there's credit cards, there's insurance, there's loans. All of these are supported then potentially by multiple tools, and each of them could be a value stream. And this is where the conversation came in with Craig, because this was pretty much defined as the standard by everybody, but it's how do you do those first 4 steps? And in particular, how do you identify a value stream and then organize around it? Because whenever we went into a mapping session, a value stream workshop, we would ask a customer, what value stream do you want us to look at? And they would ask one of 2 questions. 1, what is a value stream? Or 2, I don't know what my value streams are. How can I pick one out for you? So it would make the whole process of the workshop much harder. So talking with Craig, we wanted to identify a way or find a way in which we could identify value streams in a much more objective way. Because previously it was objective. It was a case of guess. You know, what, I don't know. Maybe it's this product, or maybe it's this team over here that's delivering it. And you would try it out, and maybe it would work, maybe it wouldn't. But there's the book, by the way, Flow Engineering, that I mentioned. That's from Steve Pereira, and that looks at those mapping capabilities, the outcomes, current state, dependencies, future state, and the flow. But this is where the value stream reference architecture comes in. This is what we developed to help us to use a scientific method and a scientific approach to identify the value streams in an organization. It allows you to assess where you are currently, identify your teams using team topologies. I'll mention that and discuss that further in a moment. Do organizational assessments, identify your value streams, bring your value streams together into a value stream network so you understand how all of your value streams impact each other and all of the supporting teams behind them, and then apply organizational change management. And that's iterative, agile organizational change management. So applying this method means you get away from big bang reorganizations and big bang re-architecture exercise, which are distracting, costly, expensive, lose your key people, lose your key information. So how was the VSRA conceived? This is where I came in with Craig, and hopefully we can unmute Craig later and he might be able to join us with some questions and help to answer those later. He might even be on the chat helping to answer some of these now. But that's the value stream reference architecture, the things that I mentioned earlier, and it's to look at those 4 key stages. Assess where you are now, map that to your vision, identify what your value streams are, and help you to organize around them in a lean and efficient way. This is the book, Team Topologies, by Matthew Skelton and Manuel Pais. If I'm to recommend to you one book, it is this. It was published 5 years ago. It is now one of IT Revolution's biggest sellers. I'm fortunate enough that mine's signed by both authors, and I've got to know them now. And in fact, myself and Craig were doing work with the two authors. Both Matthew's from the UK, from Leeds, Manuel from Madrid. Within that book, they talk about how every organization, even organizations that are not using team topologies, you don't realize it, but you are using these. That there are 4 team types: streamlined teams, enabling teams, platform teams, and complicated subsystem teams. And there are 3 interaction styles between those teams: collaboration, as a service, and facilitation. We've used that book as the basis for how we start to look at identifying value streams. Because one of the things we realized is that you can't identify a value stream unless you've truly identified your team structures that work on that value stream. And in particular, as one of those teams that you see at the top, a streamlined team, is key and is responsible for delivering a value stream. So if you look at your organization and you can identify a streamlined team, you can identify a value stream. That is the principal team type that is talked about within team topologies, because they are responsible for that end-to-end delivery. They're the thing that takes it from the idea, the bright spark on the golf course at the 9th tee who has a great idea for his business, through to the point of value realization. In other words, when the customer is using the software and getting value from it. But supporting them is the enabling teams, the platform teams, and the complicated subsystem teams. Your enabling teams, they're there for your continuous improvement, your continuous learning, identifying new technology, identifying new things that you need to implement to make your life, make the life of the streamlined team better.
Can I ask a fundamental question? Which
Yeah.
is, when you're talking about teams at this point, you're talking about teams within an IT department or within a whole organisation?
The initial view of this was to look at things from an IT department,
Yeah.
but since then, this has been viewed that it can be used across an entire organisation.
Okay, thank you.
You can use this approach across an entire organisation. And in fact, that is the way we're going with it now with the value stream reference architecture. So you include marketing, legal, HR, all of your business teams as part of it as well.
Okay, thank you.
So you've then got your platform teams. Now, your platform teams, these are the guys who provide all of the mundane stuff that is absolutely essential to anybody doing their job. So in DevOps terms, that's where your CI occurs, where your CD occurs, your testing tools, your security tools. It's also where things like network, potentially database exist. This is where those repetitive actions that can be scripted or automated, that's where that can be controlled and managed. So your platform team produces these automated things to be run as a service to support the streamlined team. And your complicated subsystem teams, well, that's for those systems, everybody's got them, that are extremely expensive, really difficult things that require that specialist knowledge to configure and to set up. We all know them, they're things like Salesforce and Tibco and ServiceNow. Okay, these are platforms that are incorporated into your system, but you need specialist knowledge to maintain them. Very little change, very rare change, but when it does occur, it can impact. So this is the actual paper itself. The vsracommunity.org website, please go there, sign up for the community. You can talk with other people who are enabling the value stream reference architecture. We want you to try out the Fine Flow toolkit. There is a toolkit which is available online where you can put in your organizational structure, and from that, define what your value stream reference architecture is, find out what your team topology types are, how they're communicating. And you can contact myself and Craig and discuss that further and find out more information as well. But within that paper, at the bottom there, you can see there are 3 disciplines we took. We took the team topologies paper, but what we also applied to that was directional graph theory, and we applied Newtonian physics. The Newtonian physics bit is the butterfly net moment that we're going to talk about later. And I'll talk about that then. But the 4 key elements that we discovered in doing this, in putting together this hypothesis, because this is what it was scientific research, it was a hypothesis at the time, was looking at value flow and dependencies through a team organization, looking at cognitive slope. And I'll mention what cognitive slope is in a bit, but it's about cognitive load within teams and the stress on teams. The fine dimensions, and finally flow entropy and team resilience. So I'll go through those 4 points now and explain what they are. So value flow and dependencies. What we did, we took the 4 team types and we applied directional graph theory. So we could show for a team type, typically who they depend upon. So I mentioned the stream-aligned team is always going to be dependent upon the other 3 team types. It's dependent upon enabling teams for new learning. It's dependent upon platform teams for those repetitive services. It's dependent upon the complicated subsystem teams for their specialist knowledge on those subsystems. So there is always a dependency there. The direction of the flow of value is in opposition to the direction of dependency. So the enabling team provides value to the stream-aligned team. The complicated subsystem team provide value to the stream-aligned team, and the platform team to the stream-aligned team. Now, stress this is the general direction of flow. You will get a little bit of information bartering between the 2, but that is the general direction. As a result of that, we looked at our directional analysis and we noticed that there was a unique pattern for each team type. Because within graph theory, you have these 2 factors called betweenness and page rank. Betweenness basically means where you've got the circles and nodes and you've got your edges, which are the arrows, lines between them. If your node is at the end, its betweenness is 0. In between, it will grow. The more you are in between in a flow, a process flow, the greater your betweenness. Page rank is the importance of a node. So how important is it to the flow of that organization? How much dependency is coming in? How many other interactions are occurring on that particular team? And so we noticed that for stream-aligned teams, they had low betweenness and low page rank, whereas your platform team has high betweenness and high page rank, which means that if you can take an organization and put it into a directional graph using directional graph theory, you can run that through the equations to calculate betweenness and page rank to discover what type of team they are, because we know from their profile what team type they are. So if you put your organization in there, you run the calculations, it will tell you what your team topology type is because it will meet these patterns. The second element, the second big aha, was the cognitive slope. And this is where we looked at those team interactions. Now, a value hive, that's where you've got one team, a single team. And it's the only team responsible for the delivery of value. That's all it does, is deliver value. If you've got a limited value team which delivers no value, you've got a problem and you need to go and see HR, because that shouldn't exist. But in between those various states, you have different types of transaction which occur. So in the middle, you've got collaboration. Collaboration is a 50-50 thing. You've got a side that is producing something, a side that is consuming, but when they're collaborating, they're sharing that information 50-50. It's great for innovation, but it does slow things down because it distracts people away from the job of delivering value. However, if you want the consuming side that is delivering the value to be more concentrated on that, then consider going as a service. Because in as a service, what we say on the cognitive slope is 25% of the effort, typically, it comes from the consuming side. It's the producing side that is producing the service that is taking on all of the effort. These are the guys creating the service, creating the documentation. All the other side needs to do is consume it. At the other end is facilitation. This is where your guys are taking in this learning, potentially coming from external sources. They're gathering information, they're gathering a bit of materials. That's their 25% of the work effort. The vast majority of the work effort is on those consuming that facilitation because they have to take on board that new learning and they have to integrate it into their ways of working, into their knowledge. They have to factor that in and take on board all of that new learning. So when you apply that, when you apply all of that thinking on value into those teams, we can start to get an idea of how the team interaction type impacts the cognitive load of the teams, depending upon whether they're on a consuming side or a producing side and the type of interaction they have. So we start to get an idea of what the cognitive load is on teams as they interact with each other. Now, this was our butterfly net moment. These are the 4 dimensions of the value stream reference architecture. These are the fine dimensions. They stand for flow, which is the units of work over time, the impediments, which are our obstacles to flow, the needs, which is the pulling force of the flow, and the effort, which is that cognitive load. It's that load, that effort that's required. Now, there was a particular reason why we went down this route. Craig and I both come from a physics background. We both come from an electrical and electronic engineering background. And when we were thinking about the flow of knowledge work, we're thinking about what else has flow, what else involves flow. So we were looking at that and we thought, oh, hang on a minute. We've got the flow of electricity. So when you're talking about the flow, the units of work over time, we're talking about current. When we're talking about impediments, the obstacles to flow, we're talking resistance. The needs, the pulling force of flow, that's your requirements to pull the information from one point to another. It's actually from a point in time. It's from your current state to your future state. It's the potential difference of your system in applying those requirements. And finally is your effort, the cognitive effort, the load. Power is required in order to work on those elements to provide that. And that's where that comes from. That's the energy in the system. So if we take that kind of perspective and look at things and consider this, we can then start to apply Ohm's law in this situation. This is why we thought it was a butterfly net moment. How could you apply the transfer of knowledge to the transfer of electrons down a wire? Well, let's apply that Newtonian thinking. Let's do some basic mathematics. Well, flow is proportional to the needs. The more needs you apply, the greater the flow of your knowledge. But your impediments are inversely proportional to your flow because the more impediments you put in place, the more it's going to slow your flow down. So that stands because that's your current over your voltage divided by your resistance, which is Ohm's law. So at the moment, that seems to scan. So we looked at it a bit further. Let's take your energy. Now, your energy is proportional to your flow. As you apply flow, you consume energy. But as you apply more needs, that's proportional as well. You need more energy. So the more needs, the more flow, the greater the amount of energy you need to apply. That scans. The net result is that if you know any two of these elements, you can calculate the third and the fourth, and you end up with that table, which is a bit of a mind-blowing thing, but there it is. And what it means is that you can calculate any of these. Now, if you remember from the front, I talked about the impediments to flow, and I also talked about the importance of the page rank being the importance of the system. So we've calculated from earlier on what the impediment potential calculation is within the system, because we know that from that calculation of the betweenness. And then we've looked at our effort, because we got that from looking at the cognitive slope and doing the calculation on the cognitive load. So if we've got I and E, it means we can calculate F and N. Yeah, call the men in white coats. But do you want to know something? We've taken this, and I'll show you in a bit how we applied this in Craig's place, and it works. It's scary. Now, we are going through further scientific analysis. I am not going to say this is proven. We are going through scientific analysis, but what we've seen so far, it's looking good. So we want more analysis. We want people to take part and give us feedback on what they're finding within there. Because this was an interesting thing. When we did it, we did our initial experimentation, and we experimented with different things, and we found this weird thing. We found this weird thing that if you apply consistent energy, so everybody is maintaining the same amount of effort, they're not burning any more, they're not burning any less, the flow value goes down. Your flow value is going down. But I'm applying as much energy, but my value is going down. I'm not delivering as well. So hang on a minute. What if I want to maintain the consistency of the flow of value? Well, my needs go up and my energy goes up. Well, the energy in any system is finite. You are going to reach a point. And with cognitive load, we know that that results in burnout. And there was a realization what this is. It comes from physics as well. It's from the laws of thermodynamics. We're talking about entropy in a system. Entropy occurs in this system because as we deploy from development into production, we're going to get good flow, which is all the good stuff that delivers value, but we're also going to get bad flow. Because you know what happens? Keeping it clean, it happens. I kept the SH silent. But you get incidents, you get issues, you get security vulnerabilities, you get problems, and they need to feed back in development, which takes away energy from your development teams in terms of being able to deliver new value. So we were seeing actual flow entropy occurring. And when we mapped that further, we realized, well, every team is going to have its tipping point. So let's assume we're trying to apply a consistent flow value. Our energy will go up until we reach that energy maximum. Our team cannot give any more. They are going to just flip out. At that point, the flow value goes down. And it's going to go down until it reaches a point where you say, this team is not performing efficiently anymore. Now, these measures, these values, they don't have any units. They're just comparative for comparative reasons on something like this. But what it means is you can start to map out the resilience of a team. And we've defined resilience as the period of time, the number of iterations, or the number of weeks, or the number of months, or whatever it is, that it takes to get to the point where flow entropy starts. And then there is going to be a point at which you can then look at that and calculate and say, that's the point I tell the team to stop, remove technical debt, clean up all of their issues, clean up all of their security vulnerabilities, then get back to value add work. Why is that valuable? Well, how many of your IT teams spend every 2 Fridays going through cleaning up technical debt? When potentially they don't need to, it needs to be only every 6 weeks. So you've gained an extra 2 days of your team delivering actual value into the system. Likewise, if you're leaving it for your team to go every 8 weeks to remove technical debt, but the resilience of the team is only for 3 weeks, you've got a problem. You're still continuously building up that flow entropy. So what does a VSRA look like? That's the science. That's how we got to where we are. That's what's in the paper. But this is what a VSRA looks like. Here's an example using the team topologies. And I stress it's an example. You've got your streamlined team at the top, your streamlined delivery team, and you can see on there, you've got development, testing, delivery, and we've added plus business delivery capabilities, which could be your sales, your marketing, your legal. Supporting that, you have your complex subsystems, your complicated subsystems. That says as a service, but they're probably more likely to be in a collaborative kind of interaction. Then in blue, you've got your other platform teams and your platform engineering team. So these are your platform teams that are doing the repetitive day-to-day actions, automated scripted actions that your streamlined team is required to do in order to do their job. But you're taking the distraction of them doing that maintenance away from the streamlined team. So that's where things like GitLab comes in, operating as a platform to provide your CI/CD capabilities as a service. But the bit that's interesting is over here. So I gave a talk similar to this where Manuel Pais was at. And he said he'd never considered an enabling team actually operating like that, which is where they act as the people who monitor and analyze what the streamlined team are doing. They look at the DORA metrics, flow metrics, perform value stream assessments with them, identify continuous improvement, look for technology reviews, do the lean engineering, new technologies, but then apply that into the platform teams, not to the streamlined teams, into the platform teams. So the service that's consumed by the streamlined team is under continuous improvement as it's consumed from the platform team. So the onus is on the platform team to provide the latest up-to-date service for the streamlined team to deliver on, without distracting the streamlined team from doing any maintenance whatsoever, which I think on the latest GitLab DevSecOps survey, 37% of the effort on streamlined teams is on maintaining their tools and the tool set. So here's an example. This is an example that we use on the VSRA community page. A typical kind of organization. Typical kind of organization. You've got your business operations over there, and we're considering them the customer. So we've got a customer which is storefront sales, bakery development, finance. By the way, this is made up of a conglomeration of things we've picked up from customers and people we've spoken to with real life issues, real life problems. And over here, we've got our IT department made up of all of these teams. They're following the rules. 2 pizza teams, all talking with each other, following the DevOps rules. So they're all operating in a collaborative way. That's what the value stream reference architecture looks like. It's big, it's blocky, it's chunky, but when you follow the path of the value stream, it flows like that. It's a very meandering river. There's a lot of handover and exchange from one team to another in order to pick up the work, to progress the work onto the next stage. There's potentially a lot of feedback loops in there as well. All of that adds to the time, adds to the waste in terms of being able to deliver an IT infrastructure that's quality assured, meets security needs, and meets the software requirements of the customer. By applying that as a VSRA and thinking about how we want that structure, and going back to what's called an inverse Conway maneuver, in other words, what do we want the architecture of the system to look like? And then applying that to our organizational structure, we can come up with something a lot neater that looks like that. By doing analysis on this, we've identified that rather than just being one streamlined team, there are 2 streamlined teams. They are supported as a service principally by the DevOps engineering team, but also by finance support and product catalog development, with your only complicated subsystem team being your database team, because that's probably an Oracle database. But at the bottom, what we've done is we've taken QA, cybersecurity, and infrastructure out of the value stream. You don't have to hand over to those teams. Those teams are not going to be a blocker to your delivery. So you're no longer going to have security complaining at the end of the life cycle. You can't deliver that because it doesn't meet this compliance requirement. Go back to the drawing board. Because security will have built that compliance requirement into what the DevOps engineering platform is providing, and it's there as a service to be consumed by the streamlined teams, which means it will be built into the actual tool that you're developing, built into the value stream service. The net result, that's your flow, a nice straight line as quickly as possible from idea through to realization. And for the two, and something to stress, this is a little rule we call the Ghostbusters rule. Never let the streams cross. Do you remember that rule from Ghostbusters? So never let your storefront development team and your bakery development team work together. If there's anything that they need to share, it should come through a platform or through a complicated subsystem. Because otherwise you've got that distraction between those teams. So Craig is on with us on the line. I'm looking at the time. I'm doing all right for time, I think, at the moment. Craig is on the line with us, and I'm just going to go through. This is something that he presented at Flowtopia last year in London. And this is just a highlight of what he's been through in his organisation. He's on the line, so he will pop up a comment if I say anything wrong. I know he will. But this was that situation. He had that great big ball of wool. But he knew from the conversations that we had that there was a way of getting there. There was a way of pulling on those threads without unraveling everything. And he needed to start at the organizational structure. It starts with the people. Too many people start at this technology end and think that's going to solve all the problems. But actually implementing it with the org structure and the process not sorted makes things worse. So determining the organization structure allows him to determine what the processes are in a lean fashion, implement them within the technology, apply the metrics for measurement using DORA and quality metrics, which then allows him to apply governance and to determine the administration of the system. That was what he started out with. I call it spaghetti and meatballs. He calls it a ball of wool. But that's following the rules of DevOps. Every team was vanilla. They all looked the same. They all had a product manager. They all had developers. They were all communicating with each other. We don't want silos. We want you all speaking with each other. But the net result was a mess. When a change is applied into the system, how do you know which team is responsible for that change? It could be multiple teams, who in that case then takes responsibility for that change. Usually when responsibility is shared, responsibility is just not taken account of. So we applied the VSRA, or rather he applied the VSRA mechanisms, and he came up with this. So he assessed his current situation where he was. And you've got a large number of complicated subsystems in there. Oh, by the way, you're not seeing team interactions because they're all collaborating. They're all operating in a collaborative way. But the biggest problem was this. If their concentration is on delivering value to the customer, they're expecting 70% of their organization to be delivering to the customer, when in fact only 27% is. So they knew immediately that they needed to concentrate more on streamlined teams, and the other functions are just there to support those streamlined teams. The net result, several months down the line, over a year now, I think, down the line, this is the structure they've got now. But they've got 50% of their teams are now streamlined teams who clearly know what they're doing. They know what they're delivering. They're receiving support from these other functions who have clear definition of what they do and how they interact with other teams. And now there is a flow of change within there. What's the benefits they get from it? These are the outcomes they've had. Clarity of purpose. That's a great statement, I think. Reduced ambiguity. Well-defined team interactions for improved flow. Team autonomy for increased resilience. So the teams are going longer before they have to deal with technical debt or the issues that they've built up. A reduction in the number of handoffs, making for easier planning. Less teams involved, less impact analysis to have to be done. Smaller resource utilization, you're reducing your costs, you're reducing the number of resources involved in a change. More local ownership with faster feedback for improved quality, and accelerating beyond that mid-tier stickiness that we talked about. So they're getting an improved return on their investment. If you want to learn more about the value stream reference architecture, there's a QR code available for you there. That's to vsracommunity.org. From there, you can get access to the white paper, access to the community site, which is hosted by the Value Stream Management Consortium. We're proud partners with them. But you can also get access to the free online toolkit and just go in, put your organization in and see what happens. Play about with it. Try it in different ways. What you can do is when you generate a report from each, you can save it to a QR code, which means that then you can take that and you can adjust it, change what the interaction types are, change the team to how they actually operate, and see how that impacts your team, how that impacts their flow, their impediments, the cognitive load on those teams. So you can model out different variations of how your teams operate. So in summary, to close off the session there, that's nicely, it's an hour. Time then. Team topologies, read it, absolute must. Flow engineering, great read. Forward is by Karen Martin, who wrote the original book on value stream mapping. This takes it to the next level. Go to the VSM consortium to understand everything about the history of value streams, where we're going with value streams, some of the latest thinking. I have to mention GitLab. I work for GitLab. We provide that tool and that technology. But at the center of it all is the VSRA community, which is where you can try out everything with the value stream reference architecture. With that, I'll hand over to questions. I saw a lot coming up in the chat. I'm more than happy to go through those and answer those.
Brilliant, brilliant. Great. Well, thank you very much for that, Stephen. There's an awful lot of content there, and I'm sure there are lots of questions. So I think you mentioned that Craig was on the line. He's been answering some. I can see that. So but what I wanted to do first of all is just start with any questions in the room. Anybody got something that they'd like to ask?
I've got some. Yeah. Thanks for that. It's really, really interesting. But it feels to me that it's just rebranding of stuff that's been done before, to be honest, you know, like benefits and, you know, I'm an MSP practitioner and, you know, we look at and all of this. And the first thing I'd ever do is I work out my POTI and what's my target operating model and how we're going to work, you know. So yeah. I guess I'm a bit confused about why this is different from some of the methodologies that you started with. So really pulling out what the benefits are. And the other thing that frightened me a little bit was, you know, again, I'd be building my team so that I've got people who are accountable for common code, if you like, or common services. So but what you can't afford to do, there was a comment that you made, you can't afford for two different teams to be working on the same code, because then you end up with the risk of you know, branching and all of this stuff and it not coming together. So there are a couple of things there that worried me a bit about the models that you put up.
Okay, so I'll deal with each of those in turn. So first of all, what's the differentiator between this and what's gone before? What has gone before has required a lot of crystal ball thinking. So it requires you to try and think in advance about what your hierarchy and what your structure is. It's setting out a vision. So you determine your teams, you break them up into development teams, as you saw with what Craig had got within his system, and you think you're doing it by the book. But the biggest player in this is Conway's Law that's within there. It's the not realizing that in setting up lines of communication between not just one team and another, but every team, you are putting stress on that team in its ability to deliver. You think about if I am developing something and I need to speak to you, that's straight away distracting me from what I need to do.
Yeah.
But if I also need to speak to you, that's an even greater distraction. But now I also need to speak to you and to you and to you. But in the same time I'm speaking to all of you, you are speaking with him, and your change may impact me. What we're doing here is trying to define a way that limits those numbers, that number of communication. We recognize communication is absolutely vital. Teams need to work together, but it needs to be just enough. There's nothing worse than over communication, which generates white noise. So that's the first thing, is in terms of setting up that structure which removes that noise. But the second thing is this, and I didn't talk about it in here, I mentioned it once, which is the agile iterative organizational change management. As you saw from Conway's law, your system architecture and your organizational architecture are linked. The two have an impact on each other. What happens in the real world is your organizational structure stays rigid, remains the same. But because of agile iterative change, some changes change your system architecture. So as your system architecture changes more and more, it starts to deviate away from that hierarchical structure until you get to a point where the two are in conflict with each other. We call this application architectural drift. Your team can no longer function correctly to support the architecture that exists. And it results in one of two things. Either the teams are reorganized to support the new architecture, or the architecture is re-architected to fit the needs of the organization. And that's when you get massive reorganization and massive re-architecture exercises, which are, as I mentioned, they're expensive, you lose key people. That's when people wonder, am I losing my job? What's happening to the project? Are things going to get canned? It leads to a lot of distraction. But even along the way, whilst you've been going through that drift, you've been incurring more and more waste into the delivery, into what's occurring. What this does is, by treating the value stream reference architecture as a living thing, every time you make an iterative change in the system architecture, you change the organizational architecture to match it. So you're constantly, no matter what the change is, you are always keeping the two in tandem. And if you're keeping the two in tandem and there is no drift, you don't end up with any massive reorganization, you don't end up with any massive re-architecture, but potentially even more than that, at no point are you going to end up in a situation where the gap is so wide it's incurring waste, because your team is having to work harder to meet that architectural change, or your architectural change is putting strain on your teams and the amount of effort that they put on. Which leads then nicely into the second part of your question about the sharing of code. And this has probably been one of the more emotive subjects when I'm talking with developers. People who've been brought up on code sharing is great. It reduces the amount of effort that you have to do. Let me take an example that I spoke about with Craig. And Craig's mentioned this within a team that he was managing. They had a great piece of code. It's a great piece of code that other teams wanted to use. So another team reused that code. Now, they reuse that code from their repository, but who is responsible for changing that code? It's still the initial owning team. So now when this team wants to make changes, it's this team that does it. So this team is now effectively acting like a parasite on the value of this team, because these have the distraction of having to support this team. What gets worse is when this team starts talking about how great that code is, another team over here wants a piece of that. And then another, until you end up with a great team that was delivering a great piece of code with great value, is no longer delivering to the customer. All it's doing is delivering to all of those other teams. you've now lost that value from that team. And that's the danger you can face. Now, there's a balancing act, because there are times where you can say, as we mentioned, collaboration can be good for short periods. It's great, it gets that innovation. But you have to reach a point where you say, right, with this code, it is not fair for this other team to be supporting that code for that team. There's going to be a point at which you say, right, either you take your own copy of that code and you manage it yourself, or it's broken off to become either a complicated system or a platform in its own right, which has its own development capabilities that supports those two streamlined teams. But it comes back to the process of the matter of never letting those streams cross, because you end up in that situation where one no longer becomes a streamlined team and you're losing the value that you're delivering to the end customer. So we're not saying never share code and never reuse code, but there's a balancing act to be had.
I think that's always been true. You know, you architect your code to be as reusable at a point in time, and as you know, with some kind of foresight of how it could be. Yeah.
And in fact, in the example that I provided in here on Bakers Unlimited, that is the reason within this why this bakery development team is a complicated subsystem. Because in the example that we have, that team is sharing code to the storefront development team. So as a result, it's considered a complicated subsystem because it's supporting to them. Now, when you do the VSRA analysis, you get the fine flow figures. And I think the storefront development team in this comes out at a value of 3.2. And the bakery development team comes out at 2.8. That's less value it's delivering, but it might be you can live with that. But when you go to this model, because you break that tie between them and you say the bakery development team are now responsible for their own bit of that code, both come in at a value of 3.2. So the 2.8 might be fine. You can live with that. But if that suddenly goes down to 1.6, that's a massive impact and a hit on that team. Does that answer your question?
Yes, yes, thanks. So I think what I read from that is you're overlaying value on top of how I say reuse. So we're assigning some kind of value over the top. So that's what I'm going
with the defined dimensions for each of these teams, you can calculate the fine dimensions for those teams. You can calculate their flow of value, their impediments, their needs and their effort. And we actually call it finer. You can also calculate their resilience. Now, for a team like a streamlined team, you want a high flow value, low cognitive effort. But for a platform team, you can cope with high effort and low resilience, but they have to be supporting that streamlined team.
Okay, so what I'm going to try and do, I think Craig has been answering quite a lot of questions, but David, I think you keep referring to stupid questions.
No such thing as a stupid question.
Exactly, yeah. So
only stupid answer.
Say that. So David, you had a couple of questions. So one 1941 in the chat about stream value teams. Did you get an answer to that later, or should we cover that now, David? I think
I can answer. So straight away, I'm looking at that first. So is this about moving platform engineering into value stream teams? No. This is about putting platform engineering into platform teams, or rather platform groups, as Matthew likes to call them now. So in the example that I'm showing there on the screen now, the DevOps engineering, the product catalog dev, and finance support are acting as your platform engineering. It's about taking the platform engineering out of your streamlined teams so that they don't have to manage the platform. They just use the platform. So it's a bit like, asking you at home to be the maintenance for your own boiler in your own house and all of your plumbing and all of your electricity and all of your heating. You wouldn't have time to actually do your day job because you're spending all of your time on your maintenance on your house. That's why you bring in electricians, plumbers to provide you a service to do that. And that's what the platform engineering teams are about.
Well, I guess just to come back on that, I guess if back to Sharon's point about, making sure it really clear. I'll declare that I'm ex-manufacturing, so I'm into the production system and sales and waste elimination. So this is it's old news, but it's kind of new news because the application's different, which is great, really. But I guess if you take a responsibility matrix and make it really clear who's responsible for what, that's kind of part of this too, isn't it?
It's kind of part of it, but this is the big problem that we have with racy matrices.
Yeah.
Racy matrices are something that are set up in front and then they never change.
Yeah, sure.
Over time, as this system changes, as changes to requirements come in, so this racy may change. Yeah. What if a brand new streamlined team comes in? That streamlined team needs to consume that platform as well. So now that changes the responsibilities of the platform team for a third streamlined team that they've got to support. But what if, with that new streamlined team coming in, there is a complicated subsystem that they are using to underpin that system? They're using Tibco or they're using Salesforce. And therefore, you need Salesforce capabilities in there as well. Well, that's new teams, but those teams also depend upon your DevOps engineering, your QA, your cybersecurity, and your infrastructure. So as changes occur, I've taken on a big world change there, but even a little world change of a new regulation has come through from government about how bakery must be performed. New health and safety regulations. That's a new compliance check, which has to come in from QA and put into the DevOps engineering, into their platform, so it's consumed automatically by the bakery development team. Change in the racy matrix, but that's not a change that impacts the storefront development team because they're not involved in the bakery. So it's about understanding what those little changes are in real time.
David, do you want to take us off mute though? Because I think, I'm trying to make sure you get it really.
Can you guys hear me in the room?
Yeah, go ahead, David. Yeah.
Hi. Well, thank you very much for the talk. First of all, I do have to caveat anything that I have to say because I am very much the novice in this topic and definitely at the very bottom of what seems like an extremely steep learning curve. I think that I'm probably at a similar point to a member of the audience in the room who spoke at the beginning in that I think I'm struggling at a really high level, I suppose, to understand. I mean, so the talk is value stream reference architecture. I think I'm struggling to understand the value. That is a good word. So one of the things, let's say TOGAF, right? Now, I'm not TOGAF certified, but I know that there's lots of people who are. And there is, I believe, value in doing something that other people understand because you can use the same terminology, you can use the same language, people can see what it is that's there, and that gives you some value. Whether or not it's the best thing is a different matter. But what I'm struggling, I think, to grasp here is, okay, at one point, we were moving from monolithic teams. We were moving from an ops team, disbanding the ops team and having all of our teams having an ops person. And lots of very, very, very big organizations do that. And they seem to be quite successful. I completely understand why you might want to have an ops team because they can all be certified in Windows platform and whatever, and they can be great at it. But it seems as though there was a benefit in moving away from that. And the same with, platform and security and everything, moving everything left. But I think what you're saying is actually we should have teams that do their thing. We should have teams who do database. We should have teams who do security. We should have teams who do GitLab infrastructure, for instance. That seems counter. So I feel as though I've probably missed something.
Okay. I'm actually saying neither, just to confuse you even further.
Okay.
I am more endorsing the former. Yes, I believe this is definitely more towards the concept of two pizza-sized teams, which take on the function and capability of all of the functions across the software delivery lifecycle. So it's about, if I go back to the example reference architecture, it's about development. Your streamlined team is about development, testing, delivery, business delivery capabilities, and it should say ops in there as well. And these are small teams. These are not large teams. Your platform engineering, this is why one of the reasons why Matthew wanted to move away from the concept of a platform team and call it a platform group, because your platform should be split up into smaller teams which support various platform capabilities, but work together as a platform group in order to deliver a service to the streamlined teams. So we're not talking about going to large monolithic teams. However, what we are also not doing is dictating what teams should look like. What we're saying is that this gives you a way to reason the best structure that you should have for your teams. So you can change your team structure to however you want and measure their performance, look at their performance, but identify from that where there are constraints, where there are things holding you up. So we're not trying to, unlike with other frameworks or methodologies in the past, and I'm not going to mention terms like SAFe, oh, too late, I did, that dictate to you exactly what your team size should be, exactly what your iterations are, exactly what each team type should be delivering. We're not trying to be prescriptive in any way. What we're saying is we're giving you a way to reason about your organizational structure and to look at your architecture. So if your architecture is built up into small microservices, small API functions, supported by a platform engineering team, then you should have streamlined teams that are small, that support those microservices, support those APIs, and a platform engineering group that provides them with a service. Does that make sense?
I think so. I think that possibly part of the problem is in my mind. I mean, obviously we have different minds, quite unsurprisingly. In my mind, not all teams are created equally. So for instance, you know, pick any organization you fancy, Google, for instance, there will be a person or a team who has decided what code management platform to use, what code versioning system software to use. If each value team decided to use a different code versioning tool, there's going to be problems. You've got to have one team do it. And similarly, if you decide from a business perspective you want to sign a license with Microsoft for SQL Server over and above anything else, well, you're not going to have other teams be very successful if they decide to do a different database. So I don't know if it's about different teams basically having they play a different part in the puzzle.
Maybe I can add a few things here. Hey Stephen, how you doing?
Hi Craig, I knew you'd cheer. Go for it.
So great questions, David. We had all of these same problems that you're describing in our team at SAS, and we actually moved away from having a DevOps team, because actually DevOps really isn't a team. DevOps is a way of doing things, right? We moved away from having a DevOps team to actually having what we now call a cloud engineering team. But that cloud engineering team is actually an enabling team. It's not a platform team. And what they do, what that enablement team does, is they facilitate the other teams to use the cloud technologies, to use the builds pipeline, or what we call the ecosystem that they created, so that they don't have to figure that out for themselves, right? We don't want to have individual, particularly stream-aligned teams, having to figure out how to do their own builds, and like you said, having their own source repos and doing all those things, right? So our cloud engineering team, and we call them cloud engineering because we're a software as a service product, right? We're clearly in the cloud, and we're specifically in Amazon AWS. But we have that cloud engineering team who allows those other teams to do those things, but they're always using this mode of facilitation. You've really got to read, as Stephen said earlier, you've got to read the book by Matthew and Emmanuel on team topologies, because that really does explain these four fundamental team types that they experienced and discovered through all of their work that they did with many, many companies over many, many years. But they also identified these 3 interaction styles. The problem we had at SAS when we started our journey, and when I started talking to Stephen, is that I'd read team topologies and I had no idea about how to organize my teams using team topologies. This diagram Stephen's showing right now, all our teams were the same. I didn't know which teams were stream-aligned teams, which teams were enabling teams. And that was a challenge that we had. I mean, I think it's a challenge that everybody has when they pick up team topologies and start thinking, this is a great idea. This seems to really codify my team organization and team structure in a way that I can really understand. But actually, I don't really know how that applies to my organization. And that's what Stephen and I got talking about. And that's what we came up with VSRA and the idea of using graph centralities to do analysis, which, by the way, was something that I'd seen be performed by a different group who were looking at software architecture using graph centralities, but they were looking at the idea of trying to figure out whether an architecture was a distributed monolith, whether it tended towards a distributed monolith. So the idea we had was, well, if you use graph theory to reason about your architecture, and Conway's law tells us our architecture and team organizations are related, right? Because those communication paths are the same between the teams as they are between the architecture, that we can use same techniques to do graph theory on our organization. And that's what VSRA really does. It tells you, when you apply it to your organization, what team types you have. First of all, when you know those team types, you can then decide whether they're using the correct interaction styles. And by the way, in the tool, we allow you to choose the interaction styles for those teams. So you could, for example, decide you wanted to have a platform team that was using collaboration instead of as a service. But the fine analysis shows you what happens when you do that. And generally, it's better if you have a platform team to make sure their interaction style is as a service. And if you have a complicated subsystem team, make sure their interaction style is collaborative. And if you have a enabling team, make sure their interaction style is facilitation. And that's, again, exactly what we did once we identified we needed a cloud enablement team, our cloud engineering team. We make sure they do facilitation. And I tell them almost every day, every time they're working on things, I tell them, your job is to make sure other people know how to do what they need to do, but not to do it for them. That's facilitation. And they do that really, really well. And it really improves the flow that the other teams have, because they can become more autonomous. They can get on with the work themselves. They're not highly dependent on that team all of the time. That team knows how to facilitate. And same goes for all the other teams that we have. Once we've identified their particular team type and understood what interaction style they should be using, the flow improves tremendously, because now you have a good model for something that works really well. And it has been a tremendous change for us at SAS to see the amount of innovation and work that now comes out of our team as compared to before, when we spent more of our time planning and trying to figure out how we were going to do the work versus actually getting on with the work.
Yeah, and it's just to add on to that, just to make a note. So David just made the comment, which is absolutely correct, that you could just as easily call your cloud engineering team cloud engineering advocates, because that's what they're there for. They are advocating the latest and greatest learnings from that cloud engineering team to the Streamline team. I mean, the Streamline team doesn't even have to take on board what it is that is coming from the facilitation from that team. However, they do run the risk of not getting what is the latest and greatest that enables them going forward. And that will then be reflected in their other metrics, such as their DORA metrics.
I mean, there's no way else got. If in terms of the facilitation teams, then, I mean, the measurement of that compared to this, the ones that are delivering for customer. So what's the measurement metrics? And I perhaps have missed that.
So the purpose of the enabling teams through their facilitation is to provide that facilitation to all of the other team types. So if I go back to that first one where we talked about the directional graph theory. which is here.
Yeah.
So the purpose of an enabling team is to deliver value into these other teams. It is through facilitation to provide the latest, the greatest for those teams. So these teams do not have the distraction of needing to go and find that for themselves. It is going to be provided for them, and they can take that on and adopt that when it is most necessary and when it is most essential for them.
But I guess the thing, I guess what's in my head is if you're sitting at senior level and you I don't know, let's say you're measuring, I don't know, outputs in some way, okay, then you can, for the overall system, you can say, well, aren't we doing much better than we used to be? But if you look at those individual teams and you need metrics to measure the team for performance management or bonus or I don't know, whatever it might be, you know, the fact that the enabling team saying, look, we're doing all this, whether you use it or not, it's up to you, then they might be doing an awful lot of good work, but actually, where's that being used?
The answer was actually in your question.
Okay, good.
Because you used the word outputs.
Yeah.
And it's not. The only measure which is important is the outcomes. It's about the value delivery. And the only team that does value delivery, that delivers the business outcomes, is the streamlined team.
So
if you want a measure of the enabling team, is the streamlined team delivering that value in the most efficient and effective manner. If they are not, then your enabling teams are not providing that latest and greatest knowledge to the streamlined team.
Isn't it really?
Sorry?
That's the Achilles heel in an organisation context.
Yes.
Because whilst I absolutely agree that you got to measure the actual value, you got to measure the output, you got to measure the outcome, of what's being delivered. You're reliant on the organisation to trust itself.
Yes.
You're heavily reliant on that. So
Yes.
culturally, there's a huge shift there, isn't there? Really?
It's a huge shift, but think about it. Whatever the organizational structure, you are trusting the organization to operate in the most efficient way possible. But at least by using team topologies and identifying these team types, there is clear responsibility on where that lies.
Yeah, of course, yeah.
You cannot suddenly lay blame on the streamlined team for not doing the latest and greatest way of thinking, unless you can prove and say, well, here's the enabling team, they're providing this facilitation as a service, they're willing to teach them, they can show that, it's the streamlined team who didn't take it on. Right, there's a clear issue with the streamlined team breaking this node between the streamlined team and the enabling team, not taking that value on board that they're delivering. But the other way is, if the streamlined team is not operating efficiently because the enabling team is not delivering anything to the streamlined team, that's the responsibility of the enabling team. But where
it's also important to point out that all of the teams only do things because of that all important need. Right, I think you mentioned earlier about what if the enabling team is doing stuff that nobody's using? Well, they shouldn't be doing that, right? The enabling team should be just like any other team. They're acting upon the needs of other teams. So they're getting requirements from these other teams about what they need. They shouldn't just be sitting there kind of generating what they think is needed. They should still be talking to those other teams and working out what those teams need. But when they find that out, they do that then through facilitation. Yes, we figured out how you need to do this. Here's how you're going to do it.
I guess. Sorry, if there's other questions, please shout up.
No, it's great. I'm loving this.
Yeah, but I guess back to Sharon's point earlier about old dog new tricks and the emperor's new clothes and so on. I think part of this clearly is you mentioned about DevOps and the move. You obviously move to DevOps and then you do create almost a mass of who owns what. Okay? Yeah. And so this might be reusing some of the stuff that comes out. But I think the real power here is that there are clear measurements, there are clear metrics, there are clear methods of doing that. I think that's, to me, the takeaway from me is, whilst there's an awful lot of stuff that's kind of repeating what I know from production value engineering and simultaneous engineering and housing quality, all that kind of stuff, that I kind of grew up with and running factories and all that kind of thing, really. the truth is, with some of the metrics that you've got and some of the, you know, the diagrams and so on, this particular one I'm looking at the moment, the graph theory, it's really, really interesting because it enables you to kind of make those connections more formally, I suppose.
Yeah.
More formally. And allowing teams to do what they like to do or what they're best at, I suppose.
And I'm actually going to bring it back to the problems. And there was one particular statement I didn't call out very purely here on here on Conway's Law. That final bullet point, that is a definition of good DevOps that has been agreed for many years. And you read that about, that's good DevOps in terms of the teams, strong identities. How many people have got a team where they think they know what they do, but suddenly something will come left field, which they don't expect to have to do, but they've got to help out on. And suddenly they find they're responsible for something in there. And then that clear responsibilities. Are they responsible for it? Is the other team responsible for it? Who is responsible for it? Having a high degree of autonomy. So every team has the right to choose its own path, what it is that it's delivering. Yes, it's going to be measured against the value it's delivering to the end customer, because if the path it chooses is to deliver a Ferrari every time when what the customer wants is a transit van, then they think they're delivering something great, but it's not what the customer wanted. So that's where you're talking about being measured against the business outcomes. It's measuring against what you're delivering to the customer. And this is the thing, and most importantly, well-defined interaction paradigms and communication channels with other teams. Because you can talk about the team types as much as you like. That's a streamlined team, that's a platform team, that's an enabling team. But if you don't define clearly how they interact with each other, then you're not defining how knowledge is going to flow between those teams.
Yeah, good. No. I mean, for me, the streamlined teams, like, you know, when it's working on stuff like from QFD, sorry, quality functional deployment stuff, if you're familiar with that, that streamlined team's doing that, they're delivering that stuff for the customer. And then you've got your internal customer supplier relationships within the other teams, haven't you? But as per your graph.
Yeah.
Yeah.
And believe me, there are subtleties of difference. I mean, from one organization to another, you can have two teams who are apparently doing exactly the same thing, but in one organization, it'll be an enabling team doing facilitation, and in another, it'll be a platform team providing a service.
Yes.
But they're apparently supposed to be doing exactly the same thing.
Yeah.
It's the subtleties of your culture within your organization and the customers that you're actually delivering through to. And that's another reason why the VSRA is important, is because everybody's VSRA is unique to them and their organization, which is why I stressed that was an example VSRA.
There were customers who, well, I'll say organisations who are starting out new value stream reference architecture and taking this on. Do you see enabling teams being like advocacy teams as well for VSRA?
Yes.
And that's how it's kind of
actually your advocacy team for the VSRA, and I will come back to this diagram here, this slide here, is there. It's your DevSecOps enabling team. A role that has started to exist, and you're seeing a few people out there, people are labeling themselves as value stream architects. And a value stream architect is responsible for taking a value stream reference architecture and turning it into an actual architecture. So they could sit there within that DevSecOps enabling team, but they could also just as easily sit within the platform team, because you could be providing architecture as a service. Again, it's unique to your organization. It's how it works best for you, which can sometimes just come down to the skills of the individuals within that team. If you've got highly skilled QA people, for example, you don't want them doing the grunt work of doing the testing. You want them generating the capabilities, the automated capabilities that are there as a platform for others to consume. So you're sharing their knowledge to everybody else.
Yeah, that's good. Thank you. Any other questions then for Stephen and Craig, I guess?
By the way, despite Craig's accent, he is actually calling you from North Carolina right now.
Well, thank you, Craig, for joining. And,
No problem, no problem.
very kind. Thank you so much for your support. Well, I must say, hang on, Stephen just asked a question. Yes.
No, simple answer.
Right.
The only restriction is that the free tool we provide at the moment is limited to 13 teams, just simply because of the instances that we create, what their capacity is. But myself and Craig are looking further into that. But in terms of actually using it, no, there is no limit. Obviously, the more teams you have, the bigger the graph that you're creating for the graph theory, and the bigger the number of interactions. But it's better to do that than on a VSRA than try and do it on a ball of wool.
From a computer science point of view, since we're in the British Computer Science Society, there is no upper limit to the algorithm. The algorithm scales to infinitely to any number of nodes in the graph, and it's computable in real time. So it's not there is no real computation limit of the algorithm. But as Stephen says, we've placed some artificial limits in the toolkit right now.
Yeah, and just on the second point there, he says, I'm thinking of the situation where the executive setting direction are too far from the point of delivery to understand the needs. Yes. They think the customer should want a Ferrari, but are too far away to see the complaints of, but I wanted a transit in a timely manner. Correct. Those close enough to hear the complaints don't have the authority to change. That is one of the biggest and hardest cultural changes that exist, not just for a value stream reference architecture, for DevOps and for Agile. I remember I was working for Borland back in 2008. We'd just acquired a company. Borland was an all Agile company. We'd acquired a new company, asking them to move to an Agile way of working. The MD found it the hardest thing of all to let go and let his teams actually talk with the customer to find out what they needed. It's the hardest thing sometimes culturally within an organization, but that is probably one of the biggest cultural things, and is one of the big reasons why many organizations are stuck in that mid-tier stickiness and not getting up into the higher levels, because there's an assumption that the tools will just fix everything for them and not cultural changes like that. So yes, Stephen, you are exactly right. You are exactly right. That is a cultural change that needs to occur. Your streamlined delivery teams really should have customer liaison in there.
Great. Okay, we've consumed all of the networking time, but it doesn't mean to say we have to stop. It can continue. But I do think for those guys on the, we've obviously a few dropped off really, but I just wanted to say thank you very much again, Stephen. So big round of applause, Steve. And Craig, thank you very much.